So looking at bell work today, it's picking up where we left off yesterday. It says G is continuous. You got a function of G. It's continuous on a closed interval, 1 to 4. G of 1 is 5, and G of 4 is 8. Of the following conditions, which would guarantee there to be a number between 1 and 4 where the derivative is equal to 1? Show me the fingers. 1 for A, 2 for B, 3 for C, 4 for D. What you got? I'm seeing a wide variety. I'm seeing some 1s. I'm seeing some 2s. I'm seeing some 4s. All right? We're looking at that word guarantee. Okay, when I see that word guarantee, I'm thinking theorems. Okay, this is a theorem question. Right now we know 2. We know IVT, we know MVT. Which theorem do you think we're going to use here, IVT or MVT? Why MVT here? Yeah, we're talking about the derivative. So if we're talking about the derivative, that is MVT. The M in MVT stands for mean. In math class, what does mean mean? Average. When we think average in calculus, we're thinking the average rate of change. So the average rate of change, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I did 2-point slope. If I do that, I get 3 over 3. Oh my goodness, I got 1. Who would have guessed? The average rate of change was 1. It's saying, is the derivative going to be equal to 1? The answer should be yes, if what? If G is differentiable. That has to be true first and foremost. If you're differentiable, then we can talk about mean value theorem. Without it, we can't. So this question is a mean value theorem question. What needs to be true? You got to be differentiable. Make sense? Today, our main focus is extreme values. We've talked about that before. When we say extreme values, we mean maxes and mins. Specifically, we're talking about absolute extrema. Okay, not just relative, but absolute. So looking at this first graph right here, okay, we're calling this graph number 1. Looking at graph number 1, it says the absolute maximum is blank at x is equal to blank. Show me with your fingers, what do you think the absolute maximum is? The absolute maximum is 5. Because if I'm asking absolute max, I mean the y value. What's the biggest? Oh, the biggest is 5. At x is equal to what number? That's 2. Okay? The what is 5. The where or the when, that's 2. That's the x value. Okay? So same game. If I did the absolute minimum is 1. And that would be at x is equal to 0. X is equal to 0. Yep, right there. That's the minimum. Pretty straightforward. Let's go to the next one. The next one, I want to know the absolute max. The absolute max of that one. What's the absolute max of the second graph here? Yeah, I'm seeing a couple things like 4.999999999, really close to 5. Does it ever reach 5? And when is that 9 going to stop? It's not. It's going to keep going forever and ever. You're going to get just really, really close to it. Okay? Or the same thing might be true if I did this. What if I drew, I'm going to change it up and draw an arrow there. What's the absolute maximum? Yeah, the answer is going to be no. Whether it's that or an arrow, the answer is going to be no, because I can't really reach it. It's going to go really high. It's going to go to infinity. Or in this case, it's going to get really close to 5, but it's never going to be 5. And without being able to say it is exactly blank, then I can't say I have an absolute max. Okay? What about the absolute minimum here? The absolute minimum is 1, and that is still happening at 0. Oh, that one I can find. It's right here. Looking at my next graph. The absolute max, okay, well, this time, the absolute max is 5 again. Yep, that's the 5. The max is x is equal to 2. Absolute minimum. What do you think the absolute min is? Yeah, something really close to 1. It's going to happen around there, but if you can't put your finger on it, if you can't tell me the exact number, then we don't have that exact number. It's going to be really close, but we're not sure. Okay, so we don't have an absolute minimum in that case. The last one is kind of the annoying one. The absolute max of that graph. What would you say the absolute maximum of that thing is? This is 1 and this is 2, so it's at 1.5. When does that 1.5 happen? Everywhere. So I'm going to say from -2 to 2. It is that whole time I'm at 1.5 from -2 to 2. And so the absolute minimum is going to be, yeah, it's the same. Okay? Kind of the most dumb thing we could do, but hey, that's both the absolute max and the absolute minimum. Technically, it could be both. All right? but that's what it is. We do those representations so that we can see it kind of put all together down below. Okay, so that leads us to the extreme value theorem, otherwise known as EVT. We got MVT, we got IVT, and now we've got EVT. There are two conditions that need to be met. It says given a blank function on the interval from A to B, there must be an absolute max and absolute min. If two things are true, it is guaranteed that you're going to have both an absolute maximum and an absolute minimum. We just did that up above here. Looking at these graphs, does anybody think they have an answer as to when an absolute or what has to be true in order for us to have an absolute max or min? Will, what do you think? So be careful, because differentiable means I have to be able to, could I have corner points? I could have a corner point and still have an absolute min. So it doesn't necessarily have to be differentiable. Zach? It's got to be continuous. That's the big one, okay? It's got to be continuous, because like what's wrong with this graph? Oh, there's a hole. It's got to be continuous. I'm going to put that as the second one. It doesn't matter what order you put them in, but it's got to be continuous. The other one you might not quite get. Anybody got a guess as to what the second thing is? The answer is it's got to be given a closed continuous function. When we say the word closed, that means there are distinct endpoints. We've got endpoints. We start here, we end there. Okay? Like on the number 2 here is kind of the one we were trying to do that on. This one, whether it's an open circle or an arrow going on forever, I don't have a value as an endpoint. And without that endpoint value, I can't necessarily find a max or min. But if those two things are true, you're always going to have a max or min. So if you want to think about it, draw a line. Like you can't draw a line that has two endpoints that's continuous. That's not going to both have a max and a min. Whatever you want to draw, there's a max and a min every single time, as long as you're closed and continuous. That's what EVT says. Okay? Not as common on the free response portion of the test, but it can be. One year I told my students, oh, it's definitely not going to be on free response. And then it absolutely was on free response. So we're ready for it. Okay. Free response question. It says the function f is differentiable. Table gives you some numbers. Then we read this. Explain why there must. As soon as you read the phrase, explain why there must, what are we thinking? It's definitely a theorem. Now we got 3 of them. Okay, IVT, MVT, EVT. So we got to make a decision. Explain why there must be a number on the interval from 1 to 4 such that f of d is greater than or equal to f of x for all other values of x. Or in other words, there's some y value that is greater than or equal to all the other y values. What is it describing if some y value is greater than all the other y values? That is an absolute max. That is what that says. It's a little bit of translation. Oh, that means absolute max. Which theorem do you think we're describing here if I'm talking about an absolute max? EVT. This is EVT. All right, cool. So again, hey, we know it's a theorem. Hey, we're talking about absolute max, so I know it's EVT. If we are doing EVT, what has to be true? It's got to be continuous, and it also has to be closed. Is this thing closed? Do I have endpoints? Yep, they just told me the endpoints, so I don't have to go into very much detail there. It's closed. Is it continuous? Yeah, how do we know? It doesn't say the word it's continuous. So how do we know that f is continuous here? It's differentiable. Okay, and we learned yesterday that when we do this question on the EP exam, we need to connect the dots for the person grading my paper because apparently they're not very smart. Okay, so we're going to say this. The very first thing I'm going to write, even before I get into my answer, is I'm going to say f is differentiable implies f is continuous. We know that that is true, but apparently the people grading have done no calculus work ever, even though they definitely understand some basics. Okay, we are saying that, yep, f is differentiable means it's continuous. Okay, once we've identified that, and we have to do that for a lot of different things. We had to do that yesterday as well. Okay, now we're going to say our answer. We're going to say since f is blank, what has to be true about f in order for us to use EVT? Closed and continuous. And we've already established, yeah, we already know it's closed. I don't have to go into that. F is closed and continuous on the interval from 1 to 4, so just on 1 to 4. And then we're going to put a comma. And then we're going to write EVT. Guarantees. What is EVT going to guarantee in this question? Yeah, guarantees an absolute max. And if you want to get more in depth than that, you could write the whole thing that they said here. It says it could guarantee there's a value of D on the interval from 1 to 4, such that blah, 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 blah. But all that means is there's max. So guarantees an absolute max. And I'm done. There's not anything else I have to do. There's no numbers that I have to say. As long as I'm closing continuous, I'm guaranteed to have an absolute max. Makes sense on what we described on that one. Okay? That's it for EVT for the day. It's pretty straightforward and simple. Okay? Example 2 here is something we've already done before, so it shouldn't look crazy different. Okay? It says find the absolute maximum value. Find the absolute maximum value of that guy on the interval from -1 to 2, and then it says justify your answer. Put a star by justify here, because it's going to do something a little bit different than what we've done before. Okay? Not necessarily harder, it's actually just different. Okay? Find the absolute maximum of that value. All right, cool. We're finding a max. When can maximums happen? Critical points and endpoints. Do I have endpoints here? Yep. Here's my endpoints. There's my endpoints. The other thing I need are critical points. When do critical points happen? When the slope is 0. You need to write that down. Because on the AP exam, that scores you a point. If on this question, I want the slope to be 0 or the derivative to be 0, if you write f prime of x is equal to 0, boom, 1 point. Okay, you only need 40 to pass the whole test. And on this question, if you write f prime of x equals 0, you scored a point. So steal that point. Okay, now do it. Take the derivative, set it equal to 0, and solve. Go. So we are taking the derivative, so we're finding f prime of x. That derivative is going to be 12x cubed minus 12x squared. We take it, we set it equal to 0. We're going to solve it. What could I factor out? Take out a 12x squared. If I do that, I'm left with x minus 1. And if I solve that, I get x is equal to 0 and x is equal to 1. Everybody with me there? Cool. Once I've got that, what am I going to do now to figure out maxes and mins? Sign chart. Let's do a sign chart. Okay, just like we did before, we have capped ends. We're going from -1 to 2. We're going to call this f prime. We're analyzing the derivative. We're going to put our numbers on there, 0 and 1. Are my signs going to alternate at both 0 and 1? No, what value are they not going to alternate? 0. 0 is squared, so I know they're not going to alternate. All right, cool. I'm just going to use that in my brain. Then we're going to plug in a number. Oh, let's plug in 0.5. If I plugged in 0.5 here, it's going to be positive. If I plug in 0.5 there, it would be negative. So positive times negative is negative. We know the signs are going to alternate, but if I plugged in 1.5, it's going to be positive because it would be both positive and positive. And if I plugged in negative 0.5, the signs are not going to alternate. It would be negative. Great. There's my sign chart. The question is, when is there going to be or find the absolute maximum value? Find the absolute maximum value. Where could an absolute maximum occur on this graph? Could it happen at 2? Yeah. Because what's 1? 1 is definitely that's definitely a min because we're going from negative to positive. But at 2, because I'm going up and I'm stopping, that could be a max. Is there any other place that could be a max? At -1 as well. When in doubt, just graph it. I'm going to draw a quick graph of f. Hey, I got a point. I'm decreasing, and then all of a sudden I'm going to increase and then stop. So 1 is definitely a minimum, but the maximum could happen at either endpoint because we're going down and stopping or going up and then stopping. It doesn't matter. But either one of those could be a maximum. Which one is going to be the absolute? Do we know yet? How could we tell? Plug them in, okay? That's what the justify means here. When on this one, if we're justifying a maximum value, not a local maximum, but a maximum value, we are going to justify that with a table, okay? Justify in this case means a table. It's a really simple setup. The left column is going to be the x's that we're checking, like what things do we think a maximum could happen at. And the second column is finding the value, what should I label that second column as? Yeah, maybe you don't know yet. It's f of x, because that's the thing we're trying to find the maximum of. We want to find the maximum of f. Everybody with me there? Cool. So the two numbers I'm checking here are -1 and 2. You could put 1 on that sign chart, but I know that 1, or on this table, but I know that 1 is a minimum, so I don't need to check it. You can, but it's going to be smaller than the other ones. So let's do it. I take -1 and I plug it into what? The original. I'm plugging -1 in right here. So if I plug it in, it would be 3 and then minus a -4. So it'd be 3 plus 4. It gets me 7. If I plug in 2, 2 to the 4th power would be 16 times 3 would be 48. Minus 4 times 8 minus 32. It gets me 16. So be careful here. The question is, find the absolute maximum value of f. What is the absolute maximum value of f? 16. The absolute max is 16. When does that 16 happen? At x is equal to 2. But the absolute max is 16. It does matter, okay? Because a lot of times they'll ask this question in context, and they'll be like, hey, f represents the amount of water in the pool over time. And what is the most amount of water in the pool? Well, 16 would be the answer. When did it happen? That would be at 2. All right, don't fall asleep on what we actually did here. If I click on that, did that load? No, hang on. Here's what we just did, okay? We had this graph of this line here, this 3x to the 4th minus 4x cubed. We had endpoints. Right here, -1 was at 7. Right here at 1, oh, that was a minimum. It was -1. And here was the absolute max. It was right here at 16, like we thought. Okay, that's what we actually did as we worked through it. Questions on something we just did there? Just to find absolute maximums, you do it with a table. Go to the backside. Number 3, put a couple stars by this one. Okay, the first one we put a star because it was justify, and that one meant we did not need words, we just needed a table. If you've noticed, anytime I put multiple stars by something, that might be something that pops up again later. I don't know, maybe on the very last day of the chapter. Ooh, interesting. Like on a day where we go over everything on the core. Okay, yeah. All right, great. Find the absolute minimum value of this guy right here on the interval, and then we're going to justify. How are we going to justify an absolute minimum value? That's going to be a table. So eventually we're going to jump to a table here. Okay? We want to find an absolute minimum. Where could absolute minimums happen? Endpoints. So there and there, or critical numbers. Yeah, local mins, which would happen at critical numbers. What do I do to find a critical number? Take the derivative, set it equal to 0, and solve. Write down f prime of x is equal to 0. It scores you a point. Try the problem. Go. No, you haven't gotten too far yet, but let's make sure we can do it. We're finding the derivative. F prime of x. What is the derivative of 2 sine? Derivative of 2 sine would be 2 cosine. It's not product rule or anything like that. There's only one x, so it's just 2 cosine. What's the derivative of negative x? Yeah, -1. That's my derivative, 2 cosine x minus 1. I want to know when that is equal to 0, so I'm going to set it equal to 0 and solve. So then I get 2 cosine x is equal to 1. I get cosine x is equal to 1/2. Technically, to solve here, I'm thinking to myself, inverse cosine, and that might be weird to you. But in other words, you are thinking about where on my unit circle, okay, specifically because they said from 0 to 2 pi. So I'm looking at the whole thing. Where on my unit circle is cosine, is my x value going to be equal to 1/2? So you're so good at your unit circle. I know you are, and so that's why you're all holding up your hand to do that hand trick here. Okay, there's 3 lines in between. We got the bottom, the middle, and the top. Which one, when I hold down that finger, is going to tell me that my x value is 1/2? Pi over 3, or sorry, pi over 6, pi over 4, or pi over 3? That guy, pi over 3. You hold that thing down, and it gives you the ordered pair 1/2, comma root 3 over 2. And I want cosine to be 1/2, so that is happening right here at pi over 3. That is my answer, or at least one of them. Pi over 3, my x value is 1/2, positive. In what other quadrant is my x going to be a positive 1/2? In the fourth quadrant, because I want my x to be positive. That would happen in the fourth quadrant. You've got the same 3 lines. The good news is it's going to be some pi over 3. You just need to know what the numerator is. What's the numerator going to be in the fourth quadrant? It is 5 pi over 3. It is double minus 1, 5 pi over 3. All right, so we've got these two values. We've got pi over 3 and 5 pi over 3. Great. Once we have them, let's throw them on a sign chart. Okay, so I'm going to make an f prime sign chart. I got capped in, so I'm going from 0 to 2 pi. I'm going to plug pi over 3 and 5 pi over 3. Are my signs going to alternate here? Yeah, nothing's squared, so I think the signs are going to alternate. I need to pick a number to plug in that's in between. That would be easy. What would be a good value to plug in here? I would probably plug in, you could plug in pi over 2. I'm going to plug in pi because I think pi is pretty easy. But yeah, there's a lot of good answers here. I was thinking pi, so that's what I'm going to do. Okay, so pi would fall between those two. It'd be right there. So if I plugged in pi, what is cosine at pi going to get me? What would my x value be over here? -1. So it'd be 2 times -1. Oh, -2 minus 1. Oh, it's -3. That answer right there would be negative. And if that's negative and my signs alternate, this guy is positive, that guy is positive. So where am I looking to find the minimum value? Tell your neighbor, when do you think a minimum value could happen here? You should be looking at 2 spots. When in doubt, graph it, like f. What's happening? Oh, f prime is positive, means f is increasing, and then it's decreasing, and then it's increasing again. So if I want to know the minimum value, hey, the minimum value could happen at 5 pi over 3, because, yeah, we changed from negative to positive. But it could also happen right there at 0. Okay, both places could be true. How can I tell which one it actually is? A table. That's how we justify it. We use a table. So the first column is x. The second column is f of x. We're going to test those two numbers, 0 and 5 pi over 3. So if I plug in 0, I'm plugging them into which equation? The original, because I want to know the f value. I want to know the value of the actual thing. So if I plug in sine of 0 is 0 times 2 would be 0 minus 0. Oh, this is 0. Then I'm going to do 5 pi over 3. So it's 2 times sine at 5 pi over 3. Well, that's this ordered pair, but the y is negative because I'm down in the fourth quadrant. So it'd be times -√3 over 2. And then it's minus my x value. Well, my x value is 5 pi over 3. Oh, my goodness. That looks horrible, horrendous. What's the answer? Which one's the absolute minimum, 0 or the second one? The second one. How do you know the second one is the minimum? Yeah, it's 2 negatives. And it's normally that easy. They'll give you questions like that are like, oh my gosh, that number's horrible. But it's negative, and the other one's 0. So you know the answer is the negative one. So my answer is -√3, because those 2's could cancel, minus 5 pi over 3. That is my absolute minimum value. Horrendous looking finale, okay, the final answer there. But all the work hopefully makes sense in terms of what we did. Okay, if we look at the actual graph of that to see what it actually did, here's what it was. We had this little curvy guy. Hey, we had a minimum at 0 of 0. There was a maximum right here at pi over 3. There was a minimum again here at 5 pi over 3. And which one's smaller? Definitely this one down here at 5 pi over 3. What is that? Oh, that's that weird number that we had. Okay, and then we had the other one there at 2 pi. That doesn't matter. Questions there? That one's a tough one, but you should be able to do it. There's a reason why we just put 4 stars by it. Okay, keep getting better at stuff. Questions? Last math difficult question here. Number 4, it says find the maximum and minimum velocity. Now be careful here, because this one's got a little bit of setup that throws students off. Don't let it throw you off. It says a particle moves along a straight line with this position equation. You got a position equation. Our job is to find the minimum and maximum velocity. The minimum and maximum velocity. They gave me position, but they're asking about minimum and maximum velocity. what do I need to do here to find the minimum and maximum velocity? What did we do up here to find the minimum and maximum of f? We looked at the derivative of f. So what do I need to do down here to find the minimum and maximum velocity? I want to look at the derivative of velocity, or in other words, we got to look at the second derivative. So it's mean here that they even told you position. So the first thing I got to do is be like, oh, why did they tell me position? Instead, I want to look at the derivative of position, otherwise known as velocity. So the derivative of that is 4t cubed minus 12t squared plus 12t. Now that I have that, I don't care about that position equation at all. That does not matter anymore because it's not asking me questions about position. It's asking me questions about velocity. So I want to look at velocity. Okay. Now that I have that, what am I going to do with velocity in order to find the absolute max and min? Take the derivative, set it equal to 0, and solve. Go. Look at this thing. We're looking at the derivative. Our job is to figure out when v prime of t is equal to 0. So if this is our free response question, I'd want to write that down because it gets me a free point. V prime of t is equal to 0. We're going to now find v prime of t. It's 12t squared minus 24t plus 12. I want to know when that's equal to 0. Now what? Factor, what could I take out? I'm going to take a 12 out just to make the problem a little bit easier. Minus 2t plus 1. Then I'm going to factor that. T minus 1 and t minus 1. Okay, cool. So t is equal to 1. Great. Once we've got that, we put it on a sign chart here. So we're going to go over here, do a sign chart. We're going from 0 to 3. It is a v prime analysis, and I'm going to put 1 on that sign chart as well. Are my signs going to alternate? The answer is no. And that might be weird here because you're like, oh, neither one of them is squared. But it's definitely squared because you have t minus 1 two different times. Does that make sense? If t minus 1 is written twice, that means it's squared. So it's not going to alternate at 1. So you can test it. Plug in a number bigger than 1, like 2. If I plugged in a 2 right here, it would be positive. Plug in a number less than 1, like 0.5. If I plugged in 0.5 here and here, they'd be negative, but I'm multiplying them together, it would be positive. Oh, yeah, it's positive. Cool. So where is the absolute minimum going to happen? The absolute minimum is going to happen at 0 because if I graphed what v looks like, it's some dot that's going to go up and then stop. So that is the minimum at 0. Where's the max? At 3. But how am I going to figure out what they actually are and how do I justify it? Make a little table. Make a little table. This is going to be called time, I guess t. What's the other column going to be called? V of t, because I want to look at the maximum velocity, so I want to plug in to velocity. So my times are 0 and 3. I take 0, I plug it into the derivative, so I'm plugging into this guy. If I plug in 0, I get 0. If you plug in 3, it's 36. You can do the math. I don't really want you to, but there it is. It's 36. This is my absolute minimum, and this is my absolute maximum. Questions on what we did there on that one? Take the derivative, set it equal to 0, and solve. In that case, we had to take the derivative of the thing we were finding the max or minimum of. One more. Number 5 is a free or a multiple choice question. Okay, and I kind of weirdly manipulated it here. It says, let f be a function. Which of the following must be true? Okay, and so normally it would be like A would be 1, and B would be 1 and 2, and C would be 1 and 3. So you're looking through this basically and just tell me which one of these is true. Okay, true or false? Is 1 true? Is 2 true? Is 3 true? Are they all true? Whatever it is. Talk with your neighbor, see what you can do. Show me with your fingers which one of those 3 statements do you think is true? You might have to show me with multiple hands here. What do we think? We're getting some 1s. We're getting some 3s. Let's do it. It says the value, which of the following statements must be true? By IVT, intermediate value theorem. There's some place on this graph between 0 and 3. So between that guy and that guy, am I going to get 2? If I start at 0 and I end at 6, am I going to get 2? Interesting. Okay, yeah, we're saying yeah. Mean value theorem. Okay, mean value theorem. Mean, what does the mean and mean value theorem stand for? Average. So when we think average rate of change. In other words, we mean 2-point slope. If we go from 0 to 3, let's do 2-point slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I get 6 over 3, otherwise known as 2. This is the average rate of change. And if the average rate of change is 2, mean value theorem says the derivative is equals 2. Interesting. All right, good. Last one, extreme value theorem. Okay, we've got this guy. F of c is less than or equal to f of x. What does that mean if some y value is less than or equal to all the other y values? There's an absolute min. Yeah, extreme value theorem guarantees there's an absolute minimum. So which one of these is true? 1, 2, or 3? None of them. None of them are true. Max, why are none of them true? It doesn't tell us that it's continuous or differentiable. If this problem would have been the exact same problem, but it said let f be a differentiable function, which one is true now? All of them. If it said differentiable, all of them are true. What if it said it was continuous? Which one would be true? 1 and 3. 1 is true, 3 is true, because it's still closed. It still said the endpoints. For number 2, though, in order for mean value theorem to work, I've got to be differentiable. Is that mean? But use your brain and make sure you know what you're doing there. Questions?